Okay, example 4 has two different types of problems that we're going to be doing. The first one has a logarithmic term, a logarithmic term, a logarithmic term. So how we did the problems in example 3, A, B, and C, is how I'm going to do this one. So this is going to be form 2. So this is the second form. And then the one on the right, I have a logarithmic expression, then I have a constant, and then I have a logarithmic expression. So this is going to be form 1. So that's how I usually determine which way I'm going to solve a logarithmic equation when I've got multiple logarithms. So the one on the left, before I can condense these, I have to take care of this 3. So that's going to be a 2 cubed. So I'm going to have log base 4. Now, the x is in the numerator, and 2 cubed, which is 8, will be in the denominator, equals log base 4 of x plus 7. Now x over 8 equals x plus 7 over 1. I'm going to cross multiply. X equals 8x plus 56. Therefore, negative 7x equals 56, and x equals negative 8. If I take that negative 8 and plug it back in, I'm going to get a negative argument, and I'm going to get a negative argument. It only takes one negative argument for this not to work. So this right here, negative 8, is extraneous. Therefore, when your only solution is extraneous, your overall answer is no solution. No solution. Okay, let's try B. B says log of x minus 2 equals log of x minus 7. I'm going to have to do a little maneuvering here. So what I'm going to do is I'm going to move this logarithm over to the right-hand side. Negative numbers, sometimes I try to avoid them, but I don't have a ton of room here, so I'm going to work with it, and it's okay. Negative 2 is going to equal log of x minus 7 minus log of x, which means negative 2 equals log of a fraction, x minus 7 in the numerator and x in the denominator. And now this is a base 10. 10 to the negative 2 is 1 over 100 equals x minus 7 over x. I'm going to cross multiply. 1 times x is x. And then I have 100 times x minus 7. So I've got x equals 100x minus 700. I subtract 100x from both sides, which gives me negative 99x equals negative 700. Divide both sides by negative 99, and x equals 700 over 99, which is about 7. It's actually a little bit bigger than 7. So if you go to your calculator, 700 divided by 99 is just slightly larger than 7. So when I put a number that's slightly larger than 7 back in, it's going to work for the first log expression in the original equation. But when I put it into the next one, a number bigger than 7 minus 7, that's going to be positive too. So we're going to box that answer because it doesn't cause us to have any extraneous solutions. So hopefully you can see how important it is here to check for those extraneous solutions. And I would say on logarithmic equations, if you just think that it's always necessary versus when necessary, it'll just take a few extra seconds of your time to check your answer to make sure it makes sense. And you'll be able to avoid any aggravation of getting the wrong answer or selecting the wrong answer on an exam. Okay, in the next video, we're going to talk about example 5, and example 6 will be in the last video, second to last video. It looks like we've got 1, 2, 3 more videos left. So the next video, if you want to take a look at these problems ahead of time and then just watch the video to check your answer, you're more than welcome to do that on examples 5 and 6.